Every time you scroll Instagram or order food, there's one architecture pattern making it all work. And if you're aiming for senior roles, system design interviews, or building real scalable applications, you must understand the first foundation of modern internet systems: client-server architecture. Hey, I am Aisha, a software engineer building serverless cloud systems on AWS, and I'll break this down so you can design like a pro. What happens when you open any social media app like Insta or TikTok? Does your phone just yell into the internet void? Let me show you what actually happens. Client-server architecture is basically a conversation. Your client, your phone or laptop, and says, "Hey server, can you show me my feed?" The server processes that request, grabs your personalized feed from the database, and sends back a response, a fresh delivery of memes. In short, clients send requests and servers send responses. The beauty? One server can handle thousands or millions of clients simultaneously. That's why this pattern powers almost every app you use. Let's look at the key components of a client-server architecture. The client. This is the requesting side. It could be your mobile app or a web browser or even another server. The client's job is simple: send requests and render responses for the user. The network. This is the communication channel. Basically, it is the digital highway, usually HTTP or HTTPS protocols carrying your data across the internet. The server. This is where the magic happens. It receives requests through an API, runs business logic, talks to a database to fetch or store data, and sends back a formatted response. Here's a real example. You search for pizza near me on Google Maps. Your phone sends a GET request to Google server. Google's servers process your location, search their database, run ranking algorithms, and respond with a payload of nearby pizza spots. Then your app renders those pretty pins on the map. Now let's check what are tiers in client-server architecture. This is the interesting part. Now, not all client-server systems are created equal. That's where tiers come in. The two-tier architecture. This is the OG setup. Client talks directly to a server that has everything, your business logic and your database, all in one place. Think of it like a one-person food truck. One person takes orders, cooks, and handles money. This two-tier architecture works until it gets busy. Then it's chaos. That's why we don't use it as much anymore, because it's hard to scale. One crash takes down everything. And security nightmare where clients are connecting directly to databases. But hey, for tiny internal tools, still fine. Next is the three-tier architecture, most common. Now we separate concerns. Presentation layer, that's your browser or app. Business logic layer, that's the backend server. And data layer, it's the database. This is the modern standard. Almost every app you use follows this model. For example, you order a coffee, then your barista uses the coffee machine to make your coffee. Here, you don't operate the machine yourself. The barista backend does the work. Its benefits. It's more secure, much easier to scale, and each part can evolve independently. N-tier architecture, used when apps get complex. N-tier is three-tier on steroids. Add payment service, recommendation engine, vector databases, caching, message queues. It becomes a gourmet system design sandwich. Netflix, for example, could be using client tier. That's your TV app. Then the API gateway tier. Then the recommendation engine tier. This is where it recommends you movies and shows based on your liking. The next tier is content delivery tier, which is why you can instantly watch the show upon opening the app no matter where you are on Earth. Then is the user data tier. This is where your watch history is. Then could be the video storage tier. Then is the analytics tier, showing what you binged at 3 a.m. That's like 7+ tiers working together so you can watch The Office for the 12th time. Thus, the usage of the tier client-server architecture can be classified as small legacy systems use two-tier architecture. Most modern web apps use three-tier architecture, and large platforms like Netflix, Uber, Amazon use N-tier architecture. Now let's check cloud and AI components for this architecture. With cloud, this client-server architecture gets superpowers. This is N-tier architecture in action. On AWS, your client might be a React app hosted on S3 plus CloudFront. Your server could be an EC2 instance running your API or a serverless Lambda function behind an application load balancer. Then your database might be RDS for structured data or DynamoDB for NoSQL. Add AI into the mix. Your server might call Amazon Bedrock to generate personalized recommendations using Claude or GPT-4. The pattern stays the same: request, process, respond. We've just distributed the processing across managed cloud services. A real-world insight. In my experience building a production system, the client and server should be partners, not master and slave. Your client mobile app should cache data locally for instant loading, validate inputs before hitting the server, and handle offline scenarios gracefully. While your server handles the authentication and authorization, the complex business logic, and being the source of truth. When you design with this partnership mindset, you build apps that feel fast and work reliably, even on spotty connections. Summary. Let's recap. Client-server architecture is the foundation of modern applications. Client makes requests, server processes and responds, network connects them. The tiers define how many layers separate the client from data. Two-tier architecture is simple but outdated. Three-tier architecture is the standard model. An N-tier architecture is used by large-scale modern distributed systems. This pattern is everywhere because it works. One code base on the server, instant updates for millions of users. But as your app grows, you'll need more tools. Load balancers to distribute traffic, caching for speed, distributed systems for scale. We'll cover all of that. If this clicked for you, hit subscribe. I'm breaking down system design, cloud architecture, and AI engineering one concept at a time. In the next video, we will check DNS, because before your client can talk to a server, it needs to find it. How does typing google.com actually reach the right server? Drop a comment if you liked, and I'll see you in the next one.